We recognize some of these angles in triangle RED, so let's go ahead and fill in the lengths. Since the angle at vertex E is 45 degrees, we'll draw an altitude from R and call this RH, which makes this also a 45-degree angle, leaving 30 degrees on this side. RH is 1, so DH is a half, and our altitude is √3/2, same as the other side EH, which makes this hypotenuse √6/2. Now let's redraw our triangle and include A and C. From the problem statement, we have a right angle here. So let's draw a segment from vertex A to RC. We'll call this point N. Since both AN and EM are perpendicular to RC, they are parallel to each other. And since AR and AC are congruent, we have this triangle is isosceles, so N is actually a midpoint. I didn't do a good job of drawing this to scale, so let me redraw triangle RCD. N is a midpoint, and so is M. So we have that MN is a median of this triangle, which means that MN is parallel to this opposite side, and it's 1/2 the length of CD. Since CD and AE are all collinear, this means that MN is also parallel to AE. With AN parallel to EM and MN parallel to AE, we have the quadrilateral MNAE is a parallelogram. This means MN is the same length as AE, so AE is also 1/2 of CD. So now we're going to try to find the length of CD. An AIME hack is to redraw your diagrams when they get too complicated. So I'm going to redraw triangle RED. I'm going to draw this segment MP so that it's perpendicular to side DE. So we can see that triangle MDP is similar to triangle RDH. M is a midpoint, so MD and RM are the same length, 1/2. So the side length ratios of these two similar triangles is 1:2. This means DP is 1/2 of DH. So these are the same length. DH was a half, so the distance from D to P is the same as the distance from P to H. They're both 1/4. We're going to find the distance from E to P by adding EH and PH. We already found this side length was √3/2, and PH is 1/4. This is going to add up to 2√3 + 1/4. MP is half of RH. Remember, this was √3/2, so MP is √3/4. Let's draw triangle RED one more time, and I'm also going to draw an RC. Again, we had EM is perpendicular to RC. I want to compare the sides of triangle EMP and RCH. We have MP is perpendicular to CH, PE is perpendicular to RH, and this hypotenuse ME is perpendicular to the other hypotenuse RC. You'll notice that all three sides of one triangle are a 90-degree rotation of the other triangle, which makes all three angles congruent. So we have triangle EMP is similar to RCH. I'll draw it down here separately, and we'll fill in the lengths that we found earlier. Now we can solve for CH. When we simplify, in the numerator, we get 3, and in the denominator, we get 4√3 + 2. We want to find CD, so we'll take HD and subtract CH. Remember, HD was a half. Subtract the expression that we had for CH. When we simplify, we end up with √3 - 1 in the numerator and 2√3 + 1 in the denominator. AE was 1/2 of CD, and when we rationalize the denominator, we get 7 - 3√3/22. The problem statement asks us to express the answer in this format. So for us, that's 7 minus the square root of 27/22, and it wants the sum of A, B, and C. That answer is 56. If you'd like me to solve any other contest problems, please leave them in the comments.